Okay, so the big ideas for our last topic of the week. What is ecological succession? What are the differences between primary and secondary succession? What are pioneer species? What are some common early colonizers? What is a climax community? How does succession in an aquatic ecosystem compare to succession in a terrestrial ecosystem? And what are some of the actual benefits of forest fires? So, as you might have guessed, we are talking about succession in our last topic here. What is succession? If a queen succeeds a king, that means the queen takes over the crown for the king, right? It's the process of changing in stages where you kind of have one stage and then the next stage and something takes over for the last stage, okay? And not just changing, but specifically changing from a very low, in fact, some cases none, literally nothing living there, to a high biodiversity. So it's basically building up an ecosystem from low to high biodiversity. It usually begins after some disturbance alters the environment, and it generally involves simpler organisms with lower energy and nutrient needs, paving the way for more complex organisms. So they're going to move in first and make things livable again after something happens that damages the ecosystem. Okay, there's two main types. The first one we're going to look at is called primary succession. Now, primary succession is what happens when whatever disturbance it is that comes into the ecosystem causes it to actually remove the soil. There's no soil even, okay? Which soil is the foundation of an ecosystem. So this ecosystem really is starting from scratch. It's back to square one, okay? So how could this happen? Well, you could probably think of lots of examples, right? For example, lava. Lava flows over and then it hardens into rock. You don't have soil anymore, right? Glacier flow comes in, totally scrapes it down to the bedrock. You don't have soil anymore. Human infrastructure. If we build a parking lot, guess what? There's no more soil anymore. There's concrete there. Okay, these are all ways that soil can be removed from an ecosystem. But once that disturbance is over, incredibly, life starts to move in. Okay, so the first thing to move in is called a pioneer species. Now, this is not a great place to live just yet, right? It is a pretty low productivity ecosystem. It might even just literally be a parking lot or a bunch of rock from lava. Okay, so these things called pioneer species are the first ones to move in. It's usually things like lichen and bacteria, right? Things that can survive on pretty low amounts of nutrients and don't need a lot from an ecosystem to survive, right? You're not going to have a deer moving in, but you could have lichen and bacteria. So they're better suited for harsher conditions and they can survive at the beginning when the ecosystem is not yet very productive. Now, why would they want to move in here to this boring sounding ecosystem? Well, there's no competition, right? So there is a plus side for them to being able to survive here. They don't have to compete with anyone, okay? And amazingly, they're going to actually be one of the key steps in getting it back to an ecosystem. So ecosystems don't stay down, right? If you've ever seen an apocalyptic movie, you know that once all humans leave a city, after a few hundred years, nature starts to take it back over, right? Or look at any ancient city that's been taken over by nature again. You can drive it out for a while, you can have an impact, but eventually it will come back if you leave it alone. Okay, maybe it won't look the same, but it will come back to a functioning ecosystem. So through chemical and physical processes, these guys actually break down the rock over the time, and they break it down and they break it down. Hey, guess what they're doing? They're making soil. By breaking down that rock, they're starting to make soil, right? It's not soil yet, it's not rich, it's not fertile, but you're getting there. It's not bare rock or concrete anymore. And then eventually these pioneer species are going to die, right? Now what happens when they die? Well, there's bacteria here that can decompose them now. Okay, so they're decomposed. And as we know from our matter cycles, if you get decomposed, you get turned into nutrients. And now the soil that you helped make is going to contain your nutrients. Hey, you're really giving your life for this ecosystem because now you are making nutrient rich soil. Okay, see how we're starting the very baby steps of an ecosystem here? Now we at least have some nutrient rich soil. So who can move in? Well, things called early colonizers. Okay, so once there's some soil, you get small plants that are things like mosses, grasses, and ferns. You're not going to get any huge lodgepole pines just yet. They need too much out of an ecosystem. But grasses, yeah, they can probably handle it. Mosses, they can grow here in this early stage of succession, primary succession. And they actually help out too, because the roots of these plants will work their way into the cracks in the rock, right? And that'll start to break it up. They'll seek out the dirt. If you've ever seen grass growing on a cracked sidewalk, right? That's what's happening. If you leave it long enough, if no one comes and picks that grass, eventually it'll turn that sidewalk into soil, okay? And not only that, but now you're going to have grass dying, and you're going to have these ferns and mosses dying, these early colonizers, and they're going to die and they're going to get decomposed. And hey, they've got nutrients in them. So the amount of soil continues to increase and it becomes more nutrient rich as even these guys are decomposed. Okay, so the ecosystem is looking better and better and better. We move on to stage 3 now. Once this has happened for a while, you start to get opportunists, we call them. Okay, these are shrubs and small trees. Again, you're not going to get 30 feet tall canopy trees, but you're going to get little shrubs, little trees. As the soil gets richer and richer, again, they're going to die and get decomposed. And I keep talking about plants, but don't forget, now all the organisms that rely on these things are going to be able to move in too, right? Like when the grass went in, you're probably going to get little bunnies that come and graze on the grass, right? And they would die there and they would get decomposed. And maybe you'd get the predators coming. So you see how it's kind of it's a snowball effect, right? Where more and more organisms are able to survive, starting from those humble beginnings of just rock, right? Then lichens, then grasses, and now we're up to shrubs and trees. What kind of plants do you usually see at the opportunist stage? Usually things that can't handle being in the shade. They need a large amount of sunlight. So why would this be a good time for organisms like them to show up? Well, yeah, right. That there's no big trees shading them. This is a good time to go in and get the sunlight while the getting's good, right? So it's a chance for the little guys to get their time in the sun. Now, after a while of this, the soil gets richer, the soil gets deeper, it can support deeper roots, and it can support even high energy and high nutrient need organisms like large trees. And of course, all the animals, all the fungi, all the decomposers that come with them. Okay. This is kind of the last stage. And though the ecosystem might look different than it did before, we call it a climax community. It's a complex community made of interactions between different species. Think about where we started. We started with no species at all. And then we started with some lichens and bacteria. That's a low biodiversity, right? It's not very complex. It's a pretty simple ecosystem. But now we've built up this complex food web of lots of different populations in the community interacting. Now, I've made this sound pretty quick here, but this can take hundreds, thousands, even millions of years to reach, okay? It's not like overnight you get back to a climax community. It can happen relatively quickly sometimes. It could take decades, okay? But often it takes a very long time. Okay, so we usually call it a climax community, but you might also hear a mature or an old growth forest. This is a big issue with deforestation. Sometimes old growth forests, these climax communities that have spent decades getting built into these complex web of interactions, they get deforested and then they plant a few new trees. Like that's the same thing, right? It's not. That took a long time. Just planting a new tree doesn't give you the complex web of interactions that you had before. Okay. The other type of succession is called secondary succession. Now, I remember this as secondary succession. The S is for you still have soil. S for secondary, S for soil. Okay, so this occurs when almost all life is removed from an ecosystem, but the soil still remains. So what's your gut feeling? What do you think's faster? Primary succession, where there's no soil at all, or secondary succession, where you at least have fertile soil at the beginning? Yeah, probably secondary succession is faster, right? That step of making new soil, that can actually be the longest part, right? As you can kind of imagine, once you start to get life in there, things can be okay, right? So again, this is primary succession. You have bare rock, right? And then it's colonized by pioneer species, examples moss, lichen, bacteria. They start to decompose, break down, make some soil, things like grass, right? Shrubs, trees, until you get to a climax community again, okay? When we're talking about secondary succession, you get to basically skip these two steps, right? You're already at the point where you have soil. So it's going to happen a lot faster. Those first couple steps of making soil can be the longest steps. Okay, so the entire process is much faster as the soil does not need to be broken down and filled with nutrients. You've already got nutrient-rich soil. So what could cause secondary succession to begin? Well, anything that leaves the soil behind, right? Things like storms, tornadoes, floods, fires, clear cutting of forests, anything that removes a lot of the organisms but doesn't remove the soil. Okay, just gonna watch a quick video where someone actually walks through different stages of succession. It's happened in a place where soil has been removed. So what kind of succession? Primary, right? There's no soil. It has to start from scratch. And just because there's been different kind of amounts of time at each place, you can actually see the stages in action. So I'll show you that really quick.
Ecosystems are shaped by biotic and abiotic factors. But before biotic factors like plants, animals, and fungi can become established, we need abiotic factors like sunlight, rainfall, and nutrients. And today, I'm here with ecologist Joe Mascaro, and he studies how ecosystems change over time. And Joe's going to help us understand how we can start with solid rock, and through biotic and abiotic factors, they can change this rock to support life. So let's track the stages of primary succession by visiting lava flows of different ages.
So, Suze, this is the earliest stage of succession, where the rock's been colonized by lichen and some small sword ferns. These guys will colonize lava right away, almost the day after it cools. And once they do, they'll begin the soil formation process. So they'll grow and they'll start to break apart the edges of these rocks, which are really friable and easy to break. And then the lichen will fix nitrogen from the atmosphere, and that will begin to build up soil on the surface of the rock.
Now let's move to the next stage of succession, one that's a bit older.
Well, Suze, this flow looks like the ecosystem has developed a bit more than the last flow. So you can see how there's so much more lichen than there was on the previous flow. It's almost like a carpet. And as the lichen grows, it's basically breaking up the surface of the rock and starting the soil formation process, which is really happening in earnest now compared to the previous flow.
The first plants that become established are early colonizers. Early colonizers have other characteristics. They're fast-growing, they need lots of light, and they're usually wind dispersed.
That's right. And there's basically two types of early colonizers we might see on a flow like this. There's some that have a symbiotic relationship with fungi, and so they're able to fix atmospheric nitrogen directly and use it immediately. And then there are plants that are just able to tolerate really low levels of nitrogen, like ohia.
Okay, off to the next stage. So here we have an even older flow.
So we're actually going to see quite a bit more soil here than we saw in earlier flows. And we've really got a lot of moss. So we're really starting to see the ohias come together, and we're getting much closer to a closed forest. We're not quite there yet, but you can see how much taller they are and thicker.
Off to the next flow. So this is what scientists would call mature forest. It's over 300 years old. It might be hard to imagine, but this whole area was once barren lava rock. Let's go check it out.
So we're definitely in a later successional forest now, which means we're dealing mostly with tree species that are not wind dispersed. They typically have big fruits, maybe dispersed by animals. They're much slower growing, and of course they tolerate shade. And as a result of all those features, they tend to need a lot more nutrients over time to grow.
Now, aquatic succession, this happens in obviously aquatic ecosystem. Those are ones in water versus terrestrial, which is on land. It follows the same general principles. So again, it's just low to high biodiversity, but it's happening a bit different because it's in water. So essentially what needs to happen is, well, first you need to have water. So some kind of basin needs to form that will collect water. How can you do that? You name it. Anything that's going to hold water, you just got to make it, right? Meteor impacts, volcanic eruptions. Those can leave big holes in the earth that can gather water. Glacial flow, as we've seen, right? Kettle lakes, that would be an example of an ecosystem where aquatic succession would have taken place. There didn't used to be water there. Now there is from the glacier, okay? Development by humans, right? Imagine a bowl at a skate park. You leave it thousands of years, fills up with water. You can come back in a couple decades and it might be a thriving pond ecosystem. So first, water collects from rainfall, but this is just water, right? Water's good. You need to drink water to live, but things don't really want to live in water unless there's food for them to eat in there, right? If you don't feed your fish, they can have all the water in the world. You got to feed them if they're going to survive, right? So the water's poor in nutrients, and in many cases, it actually starts out too deep for sunlight to reach the bottom. If sunlight can't reach the bottom, what can't survive? Producers, right? They need sunlight for photosynthesis. So no plants are going to grow in this new body of water just yet, okay? So how's water ever going to get there? Well, like kind of before, we need to start out with simple, low energy need, low nutrient need organisms. So something like maybe algae or bacteria, okay? Those can be just blown to the new wind by the pond, or remember, it is water. So you might get larger organisms like ducks or birds, right, that are looking for a drink, and they might carry the seeds there or the algae on their feet there, okay? And so now you've got some algae and some bacteria in that pool. They might not make it. They might not flourish. There might still not be enough stuff for them. They're photosynthetic, so maybe that will work for them. They can float and get it. But either way, what their real contribution is going to be here is that as they die off, kind of like the lichens and the bacteria from terrestrial succession, they sink to the bottom and get decomposed. Now, this increases the nutrients in the soil. And if there's not soil, well, sediment can be carried to the basin by runoff. Hey, the water cycle. Runoff, right? So as water is flowing over surfaces, maybe collecting more in this basin, little fine sediments, little sand, little mud is going to get dragged along too. And it helps to kind of fill up this new pond or lake or whatever it might be, right? And then it combines with these dying algae to produce, hey, nutrient-rich soil. So not only that, but it's also making the lake shallower. So maybe sunlight can actually get through to the bottom, okay? So if sunlight can penetrate to the bottom of the pond, well, now you can have rooted plants because there's soil for them to root in. They can actually get some sunlight. And so you have plants growing at the bottom of the lake even. So you have plants growing, especially at the shallower parts. Now here's where things start to get interesting. Things like salamanders, frogs, insects, all of those lay their eggs in water, but they're not going to lay their eggs in water where there's nothing to eat. If you suddenly have plants growing along the shallow shores, well, there's something for those guys to eat, right? And so word gets out that this pond is a pretty good place to lay your eggs and for things to eat plants and get their nutrients, right? And not only that, now things like birds are going to get word that, hey, I heard there's some salamanders you can eat if you go over there to that pond. They're going to bring more plants, more seeds from different organisms. And now this new aquatic ecosystem is really starting to turn into a party, okay? So the activity around the edges of the aquatic system starts to lead to enriched soil, things dying, things leaving waste, right? Pooping. And organisms like cattails and reeds might begin to flourish. Those are ones that like shallow water, not super deep water, and will grow along the edges. And of course, everything that eats them will like that too. Insects also love to make their homes in things like this. You see how we kind of have a snowball effect here, right? And now you can even start to get to a climax community where you have rooted trees that thrive in wet environments like willows. Willows love to live very near to deepish water. Okay, they may begin to grow along the banks of the new aquatic ecosystem. And look at that, you've reached a climax community, a complex bunch of interactions from what used to be water in a hole. You can see aquatic succession start to happen. This summer, well, don't do it. Your parents will probably not be happy, but fill up a pool and leave it all summer. You're going to start to see stuff grow in it. That's aquatic succession. If you leave it long enough, you might get your own little ecosystem. Realistically, it'd need to be bigger, but you can see the starts of it, right? You can see stuff growing in still water. Okay, last thing we'll talk about is very related to succession, and those are forest fires, okay? So we hear forest fires and we can think, ooh, bad, right? Especially in Fort McMurray, okay? The thing is, though, forest fires are a natural part of life in an ecosystem, okay? So in the past, we have attempted to try to extinguish all wildfires. We said there's going to be no wildfires. And at first that sounds like a good idea. Forest fires are bad for ecosystems, right? And maybe short term, sure, okay? Here's the thing though, by preventing smaller fires that would have naturally occurred and always have naturally occurred, we were leaving more fuel for larger, more destructive fires to erupt. So that when fires did happen, they burned out of control. It's essentially like things were just building up, ready for a burn because there is kind of a natural burn cycle that usually happens in nature. Now, there were many unforeseen consequences to this that we didn't really predict. We thought we were doing the right thing. But one of them was that fewer mossy areas and small shrubs for large herbivores, things like moose and caribou, right? Because those rely on things like that. And so what does that mean for the moose and caribou? Well, they can no longer be supported in this environment, so they have to move out. What does that mean for wolves that hunt the moose and caribou? They can't be supported in this environment. What does it mean for bears, right? There's this chain reaction. Quick question, why would there be fewer mossy areas and small shrubs from putting out forest fires? Why would that lead to fewer plants? Seems counterintuitive, doesn't it? Well, you got to remember, where do moss and little shrubs live? They live on the forest floor, and they need to do photosynthesis. So they need the sun, right? If there's tall trees everywhere that normally every now and then would get burned down, okay, they're hogging all the sunlight, decades and decades and decades, and the poor little mosses and shrubs never really get their time in the sun. And so eventually they start to die out. They can't be supported, okay? Another surprising factor is that we started to notice the beaver population really drop. This seemed strange too, right? But the thing was, fewer young aspen trees were able to begin growing. And beavers, as you know, build lodges and dams, right? And they use the young aspen trees. They can't use the big ones. They have to use the young ones that grow along the side of the river. Now, if all you have is a bunch of old big trees that hog all the sunlight, how are these new young aspen trees supposed to pop up, right? They're hogging their time in the sunlight. They're not kind of giving way to the natural cycle that normally fires would kind of put a refresh button on the succession and say, okay, time for some younger trees to grow, okay? Give the new guys a chance. So beavers rely on them to build lodges and dams. So beavers are actually an organism that provides so many other species with a niche within a habitat. I've heard it said that besides humans, the organism that is best at shaping their environment to meet their needs is beavers. Because that's what they do, right? They come in, they build a dam to flood an ecosystem, because when they flood the ecosystem, it causes all the vegetation they like to grow. Literally, they're creating a type of ecosystem that many other species have learned to find their role in. Okay? So when you mess with the beaver population, you really are messing with things. There's a big chain reaction. So they directly and indirectly provide many niches. So threats to beaver populations can have severe domino effects, right? So in this, with our good intentions of saving the forest by not having any forest fires at all, we actually kind of went backwards. The biodiversity actually lowered, okay? Because only certain types of organism are going to thrive here, right? Just the big guys, just the tall canopy trees that are thriving, right? We are removing a natural limiting factor from this ecosystem. Fires, remember, limiting factors are things that kind of help one organism not get too much of an upper hand so it doesn't bully all the other ones, right? Well, forest fires are one of those limiting factors. They're an abiotic limiting factor because fires are not alive. We removed that, and that gave these big canopy level trees too much of an upper hand. They hogged all the sunlight, they took all the nutrients, and that overall lowered the biodiversity in the end. We were giving them too much of an advantage. Now, as we know, biodiversity being low makes the ecosystem less resilient against disturbances, right? If you have a complex food web with a high biodiversity, then maybe if one organism isn't doing so well, someone else can step up and fill that role, right? But if there's only one species doing each role, then the ecosystem is incredibly fragile, right? That one organism now, the entire ecosystem is depending on it or it will collapse. So low biodiversity is very scary for an ecosystem, okay? So we kind of have come to realize now for a while that forest fires are an important part of ecosystem protection and renewal, okay? In fact, it's actually been known for a long time in a lot of traditional knowledge. So a lot of indigenous people for centuries on this land have been doing controlled burns to sort of engineer the ecosystems to not only promote the health of the ecosystem, but to also get what they needed out of it, right? Now, that traditional knowledge was not necessarily heeded or listened to with European governments. And so that lesson, unfortunately, had to be relearned because people wouldn't listen, right? But it isn't a traditional law that's still in use that is now starting to be re-implemented, this idea of controlled burning, okay? All right, so what do? They return nutrients to the soil, right? You burn a tree, the tree ashes fall to the ground, well, all those nutrients are now going to be returned to soil, allows to raise soil fertility. And the big one is that allows smaller shade-intolerant organisms, and not only that, it's never only that, it's always also the organisms that rely on those, right, to experience a growth period. They get their chance to have some sunlight. And often we think, oh, these poor big trees, we're just going to let them burn. But they know that. They've evolved with this natural cycle. They've accepted that that's kind of part of their fate, right? We see that in things like lodgepole pine cones, which are a climax community tree. They're huge. If you look at the birchwood forest, you're mostly looking at lodgepole pine, okay, big tall trees like that. They actually need extreme heat to open and release their seeds. So they get it, right? They get that this is a natural part of the cycle. They've accepted their mortality and they're just ready for the next generation. They have a built-in thing that says, okay, cycle's happening, time to drop my seeds. So pause the video, try answering this on your own, okay? Be much more beneficial. When you're done, you can come back and see how your answer compares to mine if you're curious, okay? But I do want you to pause and think about this one on your own. So it just gives smaller plants and producers and things like that a chance to flourish again, right? After they've maybe been a bit stifled by climax species. Right? And not only those little guys, right? But now all the things that depend on them can come back, and the things that hunt those things can come back. So a reset every now and then is good for an ecosystem's long-term health, as weird as it may seem at first. Makes sense. So a real life example of this in Fort McMurray. Did you notice that there were way more bear sightings than usual last summer? Okay, it seemed like that every day there was a bear, right? That's actually not a coincidence. That's because of the fire a few years ago. So the reason the bear population has gone so high this last year is that the berries that bears like to eat, okay, they were getting outcompeted. They didn't have a chance to grow under all these big climax trees. And then this fire came in and put a reset on it. And now these berry populations have gone way up. And what does that mean? It means more bears can be supported. Just such an amazing example of how connected these things are, right? How interconnected life is. You would never really think, I would never really think that a fire 4 years ago has now led to bigger bear populations, right? And yet it has. A reset every now and then is actually very good for an ecosystem, okay? I'll show you a picture actually that I went up and took up in Gregoire. You can start to see succession in action here. This is in town. Okay, so some questions to get us thinking about this a bit. So monoculture, mono means one, like a monocle, right? Is a term used to describe reforestation projects that replant a single species of desirable tree into logged, clear-cut areas. Describe how reforestation projects change both species diversity and the direction of secondary succession. Well, how about we draw a picture, okay? So imagine before we have a climax community. Now remember, a climax community has a high biodiversity. So maybe it has some coniferous trees, right? Like a lodgepole pine. Maybe it has like an aspen poplar, a deciduous tree, maybe like a balsam poplar. Okay, so it has all of these different types of organisms living in here. And don't forget everything that depends on them too, right? All the animals that depend on them too. And so it gets clear cut, okay? Clear cut means everything gets cut down, right? And so you're left with a bunch of stuff. Okay, so the opportunity for succession is here to happen, except instead of letting succession naturally take its course, what did we do? Well, we want these trees. Let's say we want these lodgepole pines. They're the best for forestry. So what are we going to do? We're just going to replant those. So instead of letting succession naturally take its course and building up to a high biodiversity, we're just going to plant the trees that we want to come back and cut later. Well, you tell me, how's that look for biodiversity? Is that the same as it was before? Can all the organisms that depended on all of these complex ecosystem interactions also survive here? What about the birds that build their nests in this tree? What about the squirrels that eat the seeds from this tree? What about the things that hunt the squirrels that eat the seeds from that tree? Can those all survive here now? No. What if a disease comes in that wipes out lodgepole pines? Well, what happens to that ecosystem now? Gone, wiped out, devastated. Over here, yes, it's not a good thing if a disease comes and wipes out lodgepole pine, but guess what? You've got all these other organisms to fall back on, right? So it is not the same thing. Just because you count the same number of trees does not mean you have the same level of strength in your ecosystem, right? Now, was clear cutting the ecosystem great? No, but in our replanting, we actually did even more damage, right? By not just letting succession naturally take its course, we ended up with this monoculture, this low biodiversity. Okay, so just replanting trees does not take the place of the natural cycle of succession. Ecosystems are complex. It's not as easy as just throwing out some seeds. Okay, in the Amazon, tree roots and other plants hold the loose soil in place. When a section of rainforest is clear cut, so again, when we remove all vegetation, heavy rains wash away much of the topsoil. Using what you learned about the processes of primary and secondary succession, explain why, in terms of sustainability, deforestation is a topic of greater concern in rainforests than it is in the boreal forest. Boreal forest, that's where we are, by the way. Well, what does it say? It says rain washes away topsoil. Now, we do get rain up here, but does it rain as much as the rainforest? No, the name's kind of a hint, right? So if tree roots are what holds soil in place, which it is, right? It helps keep it. You remember that from the wolf video where when wolves came back and they ate the deer and the tree roots could grow back because the deer weren't eating the trees, then the river started to erode the banks less because of the tree roots, right? So if we clear cut trees and there's all this rain happening in the Amazon rainforest, well, the soil is really likely to get washed away. Now, normally, if you clear cut a forest, obviously not great, but leave it for a little bit and succession will take its course. Usually, if you clear cut, you would leave the soil, right? But not if the rain is going to come and wash it away. Now, what if it washes it away completely? We've gone from a few decades of succession now, right? What kind of succession would it be? Secondary, because there's still soil, right? S for soil and secondary. Okay, but if we wash all the soil away and we're down to bedrock, what kind of succession do we now have to begin with? Primary, right? Where there's not even soil left. And as we know, that takes way longer. Making soil is the longest part of primary succession. Okay, so that's why it's a bigger concern in the Amazon than here, because at least here, it doesn't rain enough to probably completely remove the soil. And we can still have secondary succession where soil is still left behind, which is much faster. Okay, and it won't be as long-term of an impact to the ecosystem. Okay, so that wraps up topic 4. Again, the big ideas, make sure you can answer these. Okay, if not, maybe go back and find them. What is ecological succession in general? What are the differences between primary and secondary succession? There's 2 main differences you should be able to say between those 2. Okay, what are pioneer species? Maybe some examples. What are some common early colonizers? What is a climax community? How does succession in an aquatic ecosystem compare to succession in a terrestrial ecosystem? And what are some of the actual benefits of forest fires? Okay, so if you're looking for practice with this, try the topic 4 section of the practice assignment. And if you're feeling good about everything, you've come and you've asked me any questions you have, then you can go ahead and do the summative check-in for this week. All right, have a great weekend. 1 more week left.